In this section, we are going to discuss that how we can process and present the data, right? So in the previous lectures, we had discussed the basic definitions, that what is meant by statistical population, what is meant by sample, sampling unit, observations, and variables. And then we also discussed the types of the variables and the scales of measurement. So now we are going to see that once we have collected the data, once we have collected our observations, how we can process that data and how we can present that data. So this is going to be the subject of this section. In the data processing, first of all, we are going to see that how we can make the frequency tables. And for that purpose, we are going to take this example. So this is the example of the length of 100 shoots. And you can see different numbers, 76, 73, 75, 73. And these numbers, they have been, the observations, they have been rounded off to the nearest whole number. So these observations, they have been taken on a ratio scale, and this is a measurement variable. As you can see that this is the length of something, length of some variable, and the variable in this case is shoot length, right? So this is the data that we have. So looking at this data, you can see that there are many values which are being repeated. So is this data as such going to give you any information about the data, that what is the lowest observation, what is the highest observation, and which observation is more frequent, which observation is less frequent? So is this giving you any information? No, this data is not giving you any information. This data is requiring more space, and this data is not informative at the first look. So if we are going to group this data, then this is going to be more economical of space, and it will be going to be more revealing and more informative. So this is going to make our data, our observations, more revealing, more informative, and they can be presented in a more economical space. So this is the purpose of making the frequency tables, and for making the frequency tables, we have to group the data, because we can see that there are many values which are being repeated. So we are going to group those observations, and let's see that what is the outcome. Now, for making the frequency table, first of all, we have to find out the range of scores. So what is range of scores? It is the highest observation minus lowest observation plus 1. So this is basically the number of unit steps that are presented in this data that are present in this set of observations. So this is basically the spread of observations into our data. So the highest observations that we can see from this data is 80. And the lowest observation is 68. So we are going to calculate the range of scores as 80 minus 68 plus 1, which is equal to 13. So we have 13 unit steps, or the spread of the observations is 13. So we have 100 observations, and these observations are spread into 13 unit steps into 13 frequency classes. So we are going to make 13 frequency classes to represent this data. So what is a frequency class? A frequency class is a class or a category in our table or in our data that shows the frequency. And frequency means that how many units in the population they are going to give this observation. For example, the observation number 75, right? So 75 millimeters, so we are going to see that how many times 75 millimeters is repeated. So how many units in the population they are going to give this length, they're having this length, or they're going to give this observation. So this is basically the purpose of making the frequency table, and this is what is meant by a frequency class. Now we have to arrange the data in 13 frequency classes. The lowest observation is 68, and 68 means that all values that can be rounded off as 68, because as we mentioned earlier, that these observations, and they represent the values which have been rounded off to the nearest whole number. So 68 means that it includes all those numbers that range from 67.5 to 68.4, because if you round off 67.5, it will become 68. If you round off 67.6, it will be 68 until 68.4. So 68.5 is going to be rounded off as 69. So that value is not included into this class, right? So the class number 1 that we are going to have, that class is going to have the class limits of 67.5 and 68.4. It means that this class is going to have all the observations that range from 67.5 to 68.4 millimeters, and these are the class limits. So the lower class limit is 67.5 and the upper class limit is 68.4. So these are the class limits, and class limits are basically those values that represent the range of the class, that what values are included into this class. Then the class interval. So class interval is basically the difference between two adjacent classes, and this is calculated by calculating the difference between the lower limits of two adjacent classes. So the first observation is 68, and the lower limit for 68 is 67.5. And the next class is going to be 69, so the lower limit for 69 is going to be 68.5. So the interval is 67.5 minus 68.5, and this interval is equal to 1. So the class interval is going to be 1 in this case. And we will make the class limits for each one of these 13 classes, right? So the class number 1 has 67.5 to 68.5, then class number 2 has 68.5 to 69.4, and so on. So we have made the class limits for each one of these 13 frequency classes. Now the next step is to count the frequencies. So after we have defined the class limits for each of those 13 classes, now it is time to count their frequencies. And for counting the frequencies, we have to insert the column of frequency class, which is represented by the letter X. And this frequency class is basically the middle point of each class. So 68 is the frequency class for the first class, 69 is the frequency class or the midpoint for the second class, and 70, and so on. And the next column that you can see in this table is the tallies. So we are going to count the frequencies by the method of tally marking, and then we are going to count their frequencies. And for that purpose, we need to have the data with us. So this is the raw data. These are the 100 observations that we have, right? And now we are going to count their frequencies. So how we are going to do that? We are going to do that by tally marking. So the first observation that we can see in this data is 76. Now we have to find out that where is the class interval, where is the class that has the 76 value, and we are going to put a tally mark in front of that class. So you can see that we have put a tally mark against that class interval, and then we are going to cross this one that we have included this into our frequency table. Now we look onto the next observation, which is 73. So we are going to tally mark in front of the class which has 73 value, and we are going to cross this one. And then we are going to see the next observation, which is 75, and let's put the tally mark in front of 75 and cross this one. Then the next value is 73, and we are going to put another tally mark in front of 73, and here we are going to cross this one. Then the next value is 74, and we are going to mark a tally in front of 74, and then the next value is also 74. We are going to put another tally mark in front of 74, and this is how we are going to do it for all of these 100 observations. So this makes the counting easy, and we can have our frequency classes counted. So we have marked the tallies in front of each of these classes by repeating the same method, and now we are going to count these tallies. So the first class has only one tally mark, so this is going to have a frequency of 1. The class number 2 has 2 tally marks, so this is going to have frequency of 2. And we are going to put these frequencies in front of these classes. So this is how we count the frequencies for each of these classes. And this is how we make the frequency table. So here we have our frequency distribution. So our frequency distribution is basically the distribution of our observations into different frequency classes. So here we have the final table In the first column, we have the class interval. In the second column, we have the frequency class, which is represented by the letter X, which is basically our observations. And then we have frequency in the third column, and this is represented by the letter F. So we have our grouped data, and this grouped data is presented in the form of a frequency table, and this frequency table represents the frequency classes in an order starting from the lowest frequency class to the highest frequency class, and it also shows the frequency of that how many times these observations are repeated into our data. The important thing is that whenever you are going to present your table, you are going to describe what this table is about. So this is very important and critical part of processing and presenting your data, that your data presentation or your data processing is incomplete unless and until you have described what this table is about. And the same goes in your assignments and exams, that if you're going to attempt your assignments, or if you're going to attempt your quizzes or exams, by not giving the description, proper description of the table or proper description of the figure, you're not going to get the full credit. Why? Because this is very important. So whenever you're going to give your table, you have to describe what this table is about. Otherwise, it makes no sense of making the frequency table. So this you have to remember, and this is very important. Now let's see the comparison with the raw data that we had. So we had these 100 observations. Now you can see clearly that which data is more economical of space, which data is more informative, which data is more revealing. So obviously this is the grouped data, the data which is presented in the form of a frequency table that is not just more economical of space, that is also more revealing, and that is also more informative. So this is why we make the frequency tables. And another important thing about making the frequency tables is that it not just helps us in presenting the data in a more appropriate way, it also helps us in documenting or summarizing the data in a form that we can do further statistical analysis easily. As we are going to see in the coming chapters, that we are going to do the statistical analysis, we are going to apply some statistical tests, and this table is going to help us in that. So instead of putting in the raw data, we are going to arrange the data in the form of a frequency table, and this frequency table not just makes the data presentable and informative, it also makes data convenient for further statistical analysis, for further handling, right? So these are the two main purposes of making the frequency tables. All right, so the next concept that we are going to discuss today is aggregating the frequency classes. So as we have just seen that we made the frequency table and we grouped the frequency classes and we presented them in the form of a frequency table. But what is meant by aggregating the frequency classes? So we have to do this when the spread of observations is large and the number of observations are relatively few. As we can see here, so this is the data, this is the observations about the masses of salmons, and these are 50 observations, right? So these are the masses of 50 salmons that are, and this is the raw data that we have. So what you can see here in this data, the lowest observation is 156 grams and the highest observation is 200 grams. And what is the spread of observations? What is the range of observations, or how many frequency classes do we have in this data? Are 45, right? So this data is quite spread. This data is spread into a large number of frequency classes. The number of observations are relatively few. The number of observations are only 50, but the number of frequency classes, the number of unit steps is 45, which is quite large, right? So is this data going to be informative as such? No, this data is not informative as such. So what we're going to do is we're going to make the frequency table. And if we're going to make frequency table as such, so what kind of table are we going to make up? We are going to make up a table with 45 rows in that table. And many of those rows would be empty because the number of observations is only 50. So not just that table is going to be a huge table, but also this is going to be less informative because there will be many values which will be missing from that table. So what we should do in this case, when we have the relatively smaller number of observations and the large spread of observations. So what we are going to do in that case is we are going to aggregate the frequency classes. Right, so we are going to aggregate the frequency classes, and how we are going to do that. First of all, we have to determine the range of scores. So the range of scores is highest observation minus lowest observation plus 1, which in this case is 200 minus 156 plus 1, and it is equal to 45. So 45 is our range of scores and 45 is our spread of observations. And as we discussed earlier, that we have only 50 observations, and these 50 observations, they are spread into 45 classes. And therefore it is not convenient, or it is not suitable for us to represent each one of those frequency classes in our table and make a huge frequency table of 45 classes. So what we're going to do is we're going to aggregate them. And for that purpose, we have to decide the required number of categories or required number of the frequency classes that we want in our table. So as a general assumption, they are usually not more than 20 or less than 10. In this case, we are going to pick up the number 15, right? So we are going to make frequency classes. So it is up to you that how many classes do you want to make. And as a general rule of thumb, it should not be more than 20 or less than 10. So we are selecting the number 15, which is quite a convenient number to handle with the 50 observations that are spread into 45 frequency classes. In the next step, we are going to divide the range by the number of classes required, right? And this is going to give us the number of unit steps to be aggregated to make up a class. So what is our range? Range is 45. And what are the number of classes required? The number of classes required are 15. So we are going to divide 45 by 15, and we are going to get the number 3. So what is this 3? This 3 is basically the number of unit steps that we are going to aggregate. The number of unit steps are the number of frequency classes that we are going to aggregate, one frequency class, one category of our frequency table. So we have to, in other words, we can say that we have to merge, or we have to aggregate 3 frequency classes in order to make one for the table. And how we obtain this number 3? We obtain this number by dividing the range of scores by the number of classes that we want to have. In this case, the range of scores is 45 and the number of classes that we want is 15. So 45 divided by 15 is equal to 3. So we are going to aggregate 3 classes to make one class. And if we get a number which is in fraction, then we are just going to round that number off. Now we are going to start constructing the table with this information that the number of frequency classes are going to be 15 and the class interval is going to be 3, right? And why is class interval 3? Because we are going to aggregate 3 unit steps, so the class interval is going to be 3 in this case. Now we see how to construct the class interval column in this case. So we have 15 classes and we have to construct the class limits and class intervals for this table. And from where we are going to start, we are going to start with the lowest limit of the smallest observation. So what is our smallest observation? Our smallest observation is 156. And what is the lower limit of this class? 156. And as we mentioned earlier, that this 156 is the rounded off number. So all those numbers that range from 155.5 to 156.4, they are going to be represented by the number 156. So it includes the values starting from 155.5. So the lower limit for our smallest observation is 155.5. And this is going to be the lower limit of our class 1, 155.5. Now, what is the lower limit of our class number 2? So this is going to be the 158.5. And how do we get this number? The lower limit of the class 1 is 155.5. And remember that what is meant by the class interval? Class interval is the difference between the lower limits of the adjacent classes. So if the lower limit of class 1 is 155.5, then how we are going to get the lower limit of our next class by adding the class interval into this. So 155.5 plus 3 is going to be 158.5. So this is going to be the lower limit of our class number 2. And what is going to be the upper limit? The upper limit is going to be 158.4 because the next class is starting from 158.5. So the upper limit of the previous class should be 158.4. So this is how we are going to do that for each one of these frequency classes, and we are going to have the class limits for all of these 15 classes. So for class number 1, we have 155.5 to 158.4. Then for the next class, we have 158.5 to 161.4. Then we have 161.5 to 164.4, and so on. So this is how we are going to define the class limits for each one of these 15 classes. Now we have to insert the next column into our frequency table, and this column is going to represent the mid position of the class. Remember, in the previous example, we were mentioning this column as the frequency class, which is represented by the letter X. So we are going to do the same here, that we are going to identify the class mark, which is our frequency class, and that is going to be represented by the letter X. And how we are going to find out the mid position in this case is we are going to obtain it by adding half class interval size to the lower limit of the class. So what is our half of the class interval? So our class interval is 3, and half of the class interval is going to be 3 by 2. And what is the lower limit for class number 1? It is 155.5. So we are going to add half of class interval into the lower limit of class number 1, and we are going to get the number 157. So 157 is the midpoint, or it is the class mark for class number 1. This is the middle point, right? And for class number 2, we are going to calculate by the same method. The lower limit of the class number 2 is 158.5, and we are going to add half of class interval into this, and this is going to give us 160. So 160 is the middle point of our class number 2. It is our class mark, right? So this is how we are going to identify the class marks for each of these frequency classes. 157, 160, 163, 166, and so on. And you can see that the difference between the class marks is equal to the class interval, which is 3. So 160 minus 157 is equal to 3. So this is how we are going to add the class mark into our frequency table. The next column is for counting the frequencies, and we are going to do that for the by the telemarking method. So for that purpose, we are going to add the column for telemarking into our table. And the first observation that we have is 162. Now we have to find out where this 162 observation should be marked in. So we can see the first class, this is the upper limit is 158.4. For the next class, the upper limit is 161.4. So is this going to include our 162 value? No, because 162 is all those values that can be rounded off to 162, which range from 161.5 to 162.4. And we can see that 161.5 is not included into this class. And the next class has 161.5 as the lower limit, which means our value of 162 can be put into this class. So we are going to mark tele against this class, and we are going to include 162 into this interval, into this class. And we are going to mark it that we have counted this number. Now the next observation is 188. Now we have to find out where 188 is, and we can see the class mark 187. So in this class mark, you can see that it has the class limits 185.5 to 188.4. So the whole numbers that are included into this class, they are 186, 187, and 188. So we are going to put the telemark here as 188. Now the next observation is 173, and we are going to look for 173, and we can see that the class with a class mark of 172 has the limits in which the 173 value is included. So we are going to put the telemark in front of this class interval. And our next observation is 168, and let's see where 168 is. So we can see that the class mark, which is 169, that has the limits starting from 167.5, which means it can be rounded off to 168. So we are going to put 168 against this class interval. And we are going to do that for all of the observations, all of those 50 observations, until we are going to have tally marks for each of these classes completed. Now, what we are going to do next is we are going to total up the tallies, and they are going to be inserted in frequency column. So the first class has only one tally, so this is going to be 1. The class number 2 has 2 tallies, so this is going to be 2. We are going to calculate the frequency for each one of these classes, and we are going to put them into the frequency column. So here we have our frequency table constructed by the method of tally marking. All right, so here we have our final frequency table, and in our final frequency table, you can see that we have the first column that shows the class limits. This next column shows the class mark, or the midpoint of the class, which is represented by the letter X, and then we have the frequency column, which is represented by the letter F. And in this table, you can see that how many classes do we have? We have 15 classes. We have defined their class marks, and we have information about their frequencies. And what is important to remember, that we have to give the description of table. So description of table is a part of the table presentation. So you're making frequency table and you're giving its description. That is a must. So this table represents masses of 50 salmons, right? So this is the table description, and you can see that this table is more informative. And remember, how many observations did we have? We had 50 observations, and what was the spread of those observations? The spread of observations was 45, which means 45 frequency classes, 45 unit steps spread onto only 50 observations. And if we were going to make a simple frequency table, then that frequency table would include how many rows? That would include 45 rows. Is this economical of space? No, this is not economical of space, first thing. Second thing is that there are only 50 observations, and we could see that there were many observations that were being repeated. So it means that there were many rows in that table, or many frequency classes in that table, that would have 0 frequency. So was that going to be a reasonable way to represent your data when there are many frequency classes, many rows in your table, and many of those rows are going to be empty? So this is not an appropriate way to do it, and the all purpose of presenting your data in a presentable form, in a comprehensive and an informative form, that would fail, because that table is not going to be an informative table, and that table is a huge table with least information. So for that purpose, we have to aggregate the unit steps, we have to aggregate the frequency classes, and in this case, we have aggregated the 3 classes, 3 consecutive classes. So the class interval in this case is 3. And by aggregating 3 frequency classes into one, we have finally 15 categories or 15 classes into our frequency table, and we were able to count frequencies for each of these classes, and we are representing these classes by their middle point, which is the class mark. So this is how we make the frequency tables, the simple frequency tables and the aggregated frequency tables. And this makes data more presentable. The space for data presentation becomes more economical. And what is the third point? The third point is that it makes data convenient and easy for further statistical processing, right? So these are the advantages of making frequency tables.